This lesson is 2.2 extension, and we're going to be talking about parallel and perpendicular slopes. So first off, let's look at parallel. So to define parallel lines, these are straight lines that will never intersect. So I kind of drew an example here, although these are not going to be perfect, right? But it gives you kind of the idea. These are lines that if you were to imagine them going on forever, there would never be a point that they intersect. The distance between them would be the same all the way to infinity, right? So they'll never cross each other. They'll never intersect. When you have parallel lines have a property where they have the same slope. And that makes sense because if you're looking at this line and comparing it to this line, they're both going to have the same slant to them. Both going to have the same change in y over change in x, right? For example, y equals 4x plus 1, if I were to graph that, I would find that 4 is my slope, right? It would go up by 4 and over by 1 the whole way through. And 1 is where the point would start on the y-axis, right? And so if we're watching that, we would get a slope of 4 is parallel to y equals 4x minus 10. So it really doesn't matter what these numbers are. What matters is that these two numbers, the numbers in front of the x, are the same. And that tells us that they have the same slope, since they both have the same slope of m equals 4. Okay? So anything that has the same slope, they're parallel. The only exception to this rule would obviously be any equation that is exactly the same. So if I'm looking at y equals 4x plus 1, the only equation with the same slope that it's not going to be parallel to is 4x plus 1, the same equation. So that might be kind of a side note to put here. Side note, y equals 4x plus 1 is not parallel to y equals 4x plus 1. And the reason for this is because if you have two lines that are the exact same line, they're going to lie on top of each other, right? They're going to overlap. And since the definition of parallel lines is that they never cross or they never intersect, this obviously breaks that rule because now they're intersecting and they're laying on top of each other all the way to infinity, right? So they're intersecting at every point at that point, okay? So let's talk about perpendicular lines. So perpendicular lines are straight lines that cross or intersect at a 90-degree angle. And so here's an example of that. I drew kind of just an axis, right? So if we're looking at the XY plane, those two lines are perpendicular to each other because they're crossing at a 90 degree. And if I cross at 90 degree for one of these angles, all four of these angles all the way around are all going to be 90 degrees, okay? So I only need to really worry about if one of those angles is 90 degrees. So the thing about this might be confusing at first when you're looking at this, but just stay with me on this. So perpendicular lines have what are called opposite reciprocal slopes, okay? So opposite means that they have opposite signs. You can either have positive or negative numbers. So if I have a positive 2, it needs to change to a negative 2, right? And vice versa. And then reciprocal means that I take the fraction, and if it's not already a fraction, I turn it into a fraction by putting the number over 1. And then I need to flip the fraction, right? So if I have 2/5, this changes to 5 over 2, right? And so I got to change the sign, and then I got to flip the number. Those are the two steps I got to do to find the perpendicular slope. Okay, let's take an example, because I think that's going to be the best way to describe this. In fact, I'll just show this whole example. So as an example, we've got y equals 1/3 x minus 2 is perpendicular to y equals negative 3x plus 4. Since their slopes are opposite, so check this out. Let's take 1/3 and let's take 3, negative 3, and let's see that positive turns to negative, so that's where the opposite comes in. And then reciprocals, I put it in orange and green to show that the orange goes now to the bottom and the green now goes to the top. So not only did it change signs to a negative, but the fraction got flipped on its head. Both steps are important. You can't do one or the other, you have to do both, okay? Both of them create a perpendicular slope, okay? And that's why you can say 1/3 is the opposite reciprocal to negative 3, and negative 3 is the opposite reciprocal to 1/3, right? Okay. So if that doesn't quite make sense to you, like how that works and why that works, that's okay. Eventually you'll start to click the more you do it. For now, I want you to practice just changing or checking slopes to see if they are opposite reciprocals. But before we do that, we're actually going to go back to parallel, and we're going to do 5 problems that deal with parallel lines. And we're gonna do these 5 problems in the book, page 56, number 1 through 5, all. Okay, so pause the video here and then come back and we'll work on it together. Okay, so let's look at this. So I'm gonna give myself lots of space here. So all I'm gonna do here is I'm gonna label what the slope is for each of these lines. So if I'm looking in the book and I'm checking out the slope for all of these, I would find that if I follow the slope of number 1 for the blue line, I end up getting a slope of -3. Okay, I go down 3 over 1. Then I look at the red line, and I'll count it right now. It goes down 1, 2, 3 over 1. Oh, okay, so that's interesting. That's the same number there. And then green, if I check that, I'm going down 1, 2, 3, 4 over 1. So the green slope ends up being -4. So if I'm asking which ones are parallel, I need to go back to my notes and I need to check, okay, what tells me if they're parallel? Oh, they have to have the same slope, same number. Okay, well, these two have the same number. So my answer for this one is that blue and red are parallel. And the reason why is because they have the same slope. Okay, that's my explanation right there. That's all you really need to put. You just need to circle the two that you think are parallel to each other and say why. They have the same slope. Okay, now let's look at number 2. So number 2, if I'm counting, I'm going to count it right now. So I go up 1, 2, 3, 4, 5 over 1, 2, 3. So this one has a slope of 5/3. Looking at red, I'm going up 1, 2, 3, 4 over 1, 2, 3. Okay, so red has a slope of 4/3. Okay, so far these are different, so I'm not going to be circling blue and red, but I might be circling one of them with green. Let's see if I do. So I'm going to go up 1, 2, 3, 4 over 1, 2, 3. Okay, so it's 4/3. If that's the case, then I know red and green, since they have the same slope, they're parallel. And I'm just going to put that same exact explanation. Same slope. Okay? So those are the same slope. Now let's talk about numbers 3 through 5. So numbers 3 through 5 might look a little confusing. You're like, what do I do with these? Well, we have to remember what we learned in 2.2. What is the graph of y equals -5 going to look like? Well, I'm not going to do an exact replica of it or an exact example of it, but I'm going to give kind of a rough example of it. So if I'm drawing kind of a graph off to the side here, I would know that when I have y equals something without an x involved at all, I know that's going to produce a horizontal line. So I'm going to get a horizontal line out of here. Let's count 1, 2, 3, 4, 5. So let's just kind of put a line roughly down here. And this doesn't have to be perfect. I'm just kind of showing why or what's going to happen visually. And then I have another equation of y equals 3, and this is also horizontal. So 1, 2, 3. Let's just put it kind of up here. So you're going to just draw kind of something that looks like this. I'm going to highlight the two lines that I'm looking at, right, to show that these are the two that we're talking about. Now, are these equations parallel to each other? Well, the answer here, if you're just visually looking, it's obvious to see that the answer is yes. But how can we justify? Because sometimes you can have two lines that look like they're parallel to each other, but when you give it a closer look, you see that, oh, they're not actually parallel. They're going to cross over here, right? So how do we know that these two lines are actually parallel to each other? Well, the reason why is because I know that the y value is never going to change for these two problems. All the way to infinity, y is going to stay 3 either way I go. Or, not 3, sorry, negative 5, all the way to infinity. And for this one, y is going to stay 3 all the way. So if they're going to stay consistent all the way down the line, then I know that these two lines will never cross each other. And so the way that I can say this is both are perfectly horizontal. Okay? Since I know that both of them are perfectly horizontal, I know that these two will never cross.